class, welcome to the Applied Science Chemistry lecture. We are going to start with the fuels topic. We already learned what is the proximate analysis, which determines the percentage of moisture, volatile matter, ash and carbon content. In ultimate analysis, we are going to learn how much exactly carbon and hydrogen is present, how much nitrogen is present, sulfur is present and the ash is present. Ultimate analysis is essential for calculating heat balance in any process for which coal is used as a fuel. This is the elemental analysis. It's called as a qualitative analysis of coal, which involves determination of carbon, hydrogen, nitrogen and sulfur, oxygen. It involves chemical reaction. First, how to determine the carbon and hydrogen. First, we are going to take 1 to 2 gram accurately weighed coal sample and burn in presence of oxygen in a combustion apparatus. Carbon and hydrogen in the coal is converted to the carbon dioxide and water. The gaseous product of combustion are absorbed respectively in a KOH and calcium chloride tubes of a known weight. That increases the weight of this and then it is determined. So here we are taking the coal sample and when we are burning it in presence of oxygen. So when we are burning in presence of oxygen, here we are burning in presence of oxygen, it is converted to the carbon dioxide and water, and we are passing this carbon dioxide and water through the calcium chloride tubes and the KOH tube. So what will happen? It get absorbed. As the gases get absorbed on the anhydrous calcium chloride and a KOH solution, that is represented as the amount of carbon dioxide produced and H2O produced respectively. KOH is absorbing carbon dioxide and the calcium chloride absorb the moisture, and whatever the increase in the weight of these tubes, ये tubes का increase हुआ weight we are going to use to determine the percentage of carbon and hydrogen. So percentage of carbon is increase in a weight of KOH tube, weight of coal sample. This calculation formula is used to determine how much percentage of carbon is present. Similarly, for the percentage of hydrogen, increase in a weight of calcium chloride tube, which used to determine how much hydrogen is present. Next term is determination of percentage of nitrogen. When for this we are going to take 1 gram of accurately weighed coal and heated in a concentrated solution of H2SO4 along with the K2SO4, which is acting as a catalyst in a long neck geldar flask. It is pronounced as a geldal flask. After the solution becomes clear, it is treated with the excess of KOH and a liberated amount of ammonia. It's distilled over the absorbed and is known as a known volume of standard acid solution. The unused acid is then determined by the back titration with the standard NaOH solution. From the volume of acid produced by ammonia liberated is used to determine the percentage of nitrogen in a coal sample as follows. These are the geldar process used for the determination of nitrogen. In an exam, they will ask you for determining percentage of nitrogen, which process is used. In that we are going to use a gel dal process. The flask is called as the heating air. That flask is called as gel dal flask. In this we are going to take coal sample along with the CuSO4, H2SO4, K2SO4, and after burning whatever ammonia is formed, it is allowed to pass through it. Nitrogen content present in the coal is converted to the ammonium sulfate, and that ammonium sulfate is boiled with a solution of NaOH, and whatever the liberated ammonia is going to titrate over the H2SO4 to find out the unused H2SO4, and that used to determination of percentage of nitrogen. Next is percentage of sulfur. When the coal is burned, if the sulfur is present, it is going to form a sulfur dioxide, which is a serious pollutant. The method of removing sulfur from the coal include cleaning, solvent refining, and gasification and liquefaction. So sulfur is not accepted in a coal as it is going to produce a polluting sulfur dioxide. How we are going to measure sulfur in a coal? We are first converting sulfur into the sulfate. The washing treated with a barium chloride, and barium sulfate is precipitated. The precipitate is filtered, washed and heated to the constant weight. The amount of barium sulfate formed, that is weighted and converted into the percentage of sulfur. Determination of ash and oxygen. Coal sample of accurate weight in a crucible is heated in a muffle furnace at a 750 degree Celsius. Crucible is taken out after that and keep in a desiccator. So whatever the weight of ash remains, that is used to determine the percentage of ash, and percentage of oxygen is 100 minus percentage of percentage of the carbon, hydrogen, nitrogen, sulfur and ash. What is the importance of the ultimate analysis? When we are performing this analysis, why we are performing the analysis is very important. When we are determining percentage of carbon and hydrogen, we know greater the percentage of carbon and hydrogen, better the quality of fuel, better the quality of coal, and it is going to produce large quantity of the calorific value, producing higher energy. While hydrogen is mostly associated with a volatile matter, hence it affects the use as it is when the coal is using. Nitrogen is having no calorific value, therefore its presence in a coal is undesirable and it may produce nitrous oxide, nitrogen NO2. Therefore good coal should have a low percentage of nitrogen. These are the short form or the ultimate analysis uses. Carbon percentage, greater the percentage of carbon, greater the quality of coal, having a higher calorific value. Hydrogen, most of the hydrogen is in the form of moisture and volatile matter. Only small percentage is combustible, hence it decreases the calorific value. Therefore, smaller the percentage of hydrogen, better the quality of coal. Nitrogen, it does not burn, hence it does not have a calorific value, negligible or the small percentage of nitrogen. Sulfur, it increases calorific value and produces the pollution. Therefore, percentage of sulfur should be very low. Most of the oxygen is in the form of moisture. Therefore, calorific value decreases. Therefore, smaller percentage of oxygen and hydrogen required for the better quality of coal. Sulphur. If the large amount of sulphur is produced and after combustion they are going to convert sulphur dioxide, sulphur trioxide, which is very harmful. It is also corrodes or deteriorates the machineries and causing the atmospheric corrosion. Therefore, percentage of the sulphur allowed is 0.2 to 0.3 percentage. The presence of sulphur is undesirable if we are using coke for the iron industry. It is affects the quality of steel and increases the corrosion. Ash content. Ash is useless non-combustible matter which reduce the calorific value of coal. More the ash, it is going to produce the hindrance. If more is ash is there is a lot of cost increases for the dispersal. How to disperse that ash is difficult. Thank you class for your attention. Send your queries on the prprushali.fy@gmail.com. Thank you class.